Alright, so first thing I'm going to start with is this. This is the first image that I can find online of this mill, and this was taken in December of 1922, and I'll link this down below because it's actually quite an interesting article. It tells you what the plans are for this mill, and pretty much everything that they had in there was correct. So I'll link that down below so you can give it a read, and we'll move right into this. This is the rod mill in 1925. Let's see, this is looking southwest, from the southwest looking northeast. You can see the furnace exhaust stack right here. The furnace was kind of in this area here. This is the train shed. There was a series of railroad tracks that came from this end and came over here. The train shed and train dock. I'm not sure how they received their copper billets. This is a cooling pond. You got your raised roof over here for venting of heat and smoke. I really like the brickwork here. This picture doesn't give it any justice, but the brickwork really was quite nice. And I will link all of these images down here below. These are from the Harvard website. It's the Harvard collection. This is the billet heating furnace, again in 1925. You can see a billet pallet right here. I'm not sure exactly how many billets they were able to hold on that pallet, but there it is. This is the charge side of the furnace, so the guy here would take this scissor clamp or whatever it's called and pick up a few billets, set them down there on the rail. You got overhead cranes for that. This looks like it's probably a counterweight for the door. And maybe some kind of hydraulic pusher down here on the bottom that pushes all the billets forward. Because this looks stationary to me, so it's probably some kind of a pusher. It just pushes the entire thing along. You can see the furnace stack right here. And that would be this, going up to the roof there. This out here, that's the train shed. So there's tracks running all along the other side of this wall here. Burners. I'm not sure how many burners this thing had. It didn't have a lot, so I see 2 burners here, and there's probably 2 on the other side. I don't see any on the top. There's got to be more than that. There's a builder's mark here on the furnace. I obviously can't read it. It's too pixelated. Then bench over here to sit on and wait for these billets to go through and heat. Alright, on to picture number 3. Also taken in 1925. This is what I would call the egress side of the furnace. A little bit further down. If I had to wager a guess, I'd say that bar is probably about 1600 degrees. Let's see, special tongs that he uses to pull it out of there. You see the fire brick inside there, refractory brick. Now you can see the tapered end of these billets aid in feeding it into the roughing mill. This is the roughing mill here. I'm assuming that these wheels are to adjust the rollers, but I'm not sure. I'm still waiting on an answer to that. This is what I would call stand 1. This looks like it's already been through 1 pass. It doesn't look like they're too worried about anything sticking to the bar or any impurities getting in there, because they probably didn't draw the wire down that fine back in the day. You can see the back wall here. That kind of separates the wire drawing side from the rod casting side. This is looking north. As you can see, nobody's wearing any face shields, and trust me, this picture does not do this any justice. That is a very hot furnace. Even though it's not melting it, that's extremely hot. That's a lot of heat to have in your face. Go over to here to picture number 4. This is looking southeast at the intermediate and finishing mills. These things here, you can see the rod going down the run-out tables. This is called run-out table. When the rod exits the mill, you got to let it run out before you feed the end of it into the next set of rollers, because each time you pass it into the next roller, it goes faster and faster. So these are, I guess the technical name for these are reversing mills, because you just feed the rod back and forth through the mills, so it draws them down smaller and smaller. Here you can see the loop of orange hot rod exiting one of the mill stands. The catcher will take his tongs and grab the rod as soon as it comes out and feed it into the next stand. But he needs to make sure that the loop is big enough, because each stand gets progressively faster as the diameter gets smaller. You will see him look down towards the bottom of the run-out table to make sure he has enough loop before feeding it into the next stand. You can see a large motor here, a large electric motor. And I believe there's another large electric motor on this side. You can see all the pallets of billets back here, all the copper that they had on hand. When they upgraded the mill, this is where they had the opening. So they created an opening back here to allow for the new casting machine to come in, and we'll see that later. You can see the furnace back here in the background and the roughing mill. So this is the last stand here, and they feed it through. These are actually coilers, so they had 1, 2, 3, 4 coilers that are actually in the floor. You'll be able to see those in action. So depending on which coiler is empty, that's what tube they'll feed it through. So it gets coiled up here, then lifted up and taken out and put onto this conveyor. This is kind of a visual. You can kind of see how the principle works of a reversing mill. How one worker feeds it through this way and back. So this will be kind of the roughing section, and then this will be your intermediate and finishing mills. Back and forth. You're feeding it through this way, and once you feed it into this next mill, it's going to start rolling faster. That's why you got to have that run-out table. You got to run it out, feed it into the next mill, and then if you time it right, your loop will be small and ready for the next stand. Here's the next picture. This is probably the most famous one. This one's widely available online. You can see the run-out tables. This is looking north, so it's basically the same as what you were looking at. So the furnace will be off in this area, and the roughing mill, and then these intermediate and finishing mills. You can see this crane back here is actually the crane that takes the hot coils and puts them in the pickling tank. This is kind of in the middle of the mill's life. I'd say this is probably taken in the late 60s, maybe early 70s. Everything's kind of different. The mills are in the same place, but this furnace has moved because it looks like they've moved it closer to the roughing mills. So this is an entirely different furnace than the one from 1925. You can see it's got a lot more burners on it. In fact, they doubled its capacity. You can see that there's actually 2 rows of billets going into this furnace when the original furnace only had 1 row. So they definitely stepped up the capacity of the plant around this time. And you better believe those catchers were working their asses off. You can see the large manifold here for the air. So it's got to have some kind of a blower somewhere. And this system here, I'll show you the video here, is at least partly automated. So what they used to do over here, when they used to manually feed the bar into the rougher, looks partly automated here. The intermediate and roughing mills are still manually fed by people. And at the top here, you can see the fans that they gave to blow on the catchers, because with 2 rows of billets coming out of that furnace, you better believe they're working their ass off. This is the other side. This is the west side of the mill here. I can't tell if that's another electric motor on this side. I know there's a large electric motor on that side, but I don't know if this is just gearing over here or just if it's another motor. This furnace here would have been considerably hotter than the last one. So right here, I'm not sure if this is some kind of actuator for a valve to maybe control the firing rates of this furnace here, but this looks like maybe some kind of a valve. This is the first picture of the demolition. This was taken sometime in early 1972. So you can see where the run-out tables are still. You can see the mills are gone. There's one stand left there. You can see the foundations for the mill here where they used to be secured into the ground. The pickling tank would have been somewhere over here. So at this time, when they started dismantling the old machinery in the mill, Western Electric and Southwire had been developing a new system since 1963, so this had been in the works for quite a while. Here is where the finishing mills were, so you can see where they were mounted into the floor. This is the conveyor, the old Coilers. So you can see the manifold here for the sprays. There were some sprays that used to quench the coils as they came out of the coiler because they were still quite hot at that point. So the coils would come up here, get quenched a little bit, come up here, and then they would get picked up by another crane and they'd be brought over to the pickling tank over here. You can see that already being torn up. You can see where the gears were for the mill. Maybe a pit for another motor over here. I still can't tell. I'm not quite sure. Another picture. Early 1972. You can see the run-out tables still. The foundations for the mills, and one of them still left here. Picture number 9. You can see the large fans they had for the workers. This, I'm just wagering a guess, but this looks like some kind of a rack for the rolls. The milling rolls need to be replaced often, so this is probably where they stored them. There was a crane that ran all above the mills here, so they probably lifted them out of here and brought them in. So most of the pictures here in my personal collection, a lot of them were actually from Western Electric. Western Electric took these pictures. Now this date is not correct. This is probably when the pictures were processed, but it's definitely not when they were taken. So this is the backers as Western Electric Incorporated, Hawthorne Photographic Laboratory. Not sure what building that was in, but probably the main building. Here's another picture. That's taken at the same time as the last couple of pictures, that early 1972. This is the last mill before it was ripped out of its foundation. I think at the end they were using soluble oil, so this is probably the piping system that brought in the soluble oil. You can see here where the 3 rollers were. The mill rack. The roll rack over here. There's some strange hood over here in the background. I'm not sure what that was. Picture 12. This is further to the southeast. You can see here is the foundation for the rougher. So the big roughing mill would have been here, and over here would have been the the intermediate and finishing mills. Is that strange hood again? Picture 13, early 1973. We're looking north here. We can see the part of the demolished furnace here. This furnace, looking at it from this angle, you can definitely tell it was way larger than the original furnace. You see the giant gear set here. Yeah, so this is early 1972. We're looking east here. Here's a picture from December 1972. We're looking at the west side of the mill here, looking south. Here's an oil removal truck. Now, before they closed this down in 2008, they actually removed 4 large tanks from over here on the south side of the mill. And the only information I have on that oil was that it was fuel oil. But I remember looking at it on the old map, and it did say it was fuel oil. So they might be draining those tanks out of there and probably just left the tanks there because they were still there in 2008. You can see they have a large crane here taking off the stack for the furnace. Large cooling tower. That was not original to the building, but this cooling tower, we still use this in 2008. So this was still here and being used when they installed the SCR system. December 1972, you can see the stack they pulled down. This is actually looking north. This is what was called the armored cable plant. So I think this was built at the same time the main rod and wire mill was being built. So they built the armored cable plant. And I believe they're the ones that actually put this coating on the cable. See the cooling tower here. December 1972. This is an unknown brick structure. I have no idea what this was. I don't think this was a furnace, but it does kind of look like refractory brick, so I really don't know what this was. Looking south once again. I do not know what this machine was here, but this is kind of standing where the new shaft furnace would be installed. So when you see the pictures of the casting pit for the new SCR system is going to be kind of around this area here. The shaft furnace over here, and the holding furnace maybe in this area. And this would eventually be torn out to make the opening for the new machinery to come in. December 1972. This is some old stuff that they've ripped out sitting on the train dock. This piece here looks like it would have meshed with that giant gear we saw in picture 13. Right here, so it might have been part of that. Really don't know. It's quite a substantial gear though. It's sitting on one of them old billet pallets. This is a picture of one of the mills that they ripped out, October of 1972. You can see the three rollers here. They would have passed back and forth, passed through here, and looks like maybe a coupling sleeve. It matches this shape here, so I'm not sure how they connected these between the stands, but this might have been it here. You can see how far down it went into the ground, where it's secured into its foundation. So everything down here would have been in the floor. Not sure what these are. Maybe soluble oil lines. And this looks like the shroud that was over that giant gear for the roughing mill in picture 4. So this giant shroud here probably went over the gearing for the roughing mill right there. Let's see, 21. This is run-out tables looking northwest. And this is my last demolition picture. This is the first picture that I have of the new roughing mill. We're ushering in a new era here. This is the roughing mill. This is 1 and 2 stand. So the bar would enter here, go through mill stand number 1, mill stand number 2, and exit as round bar. And we'll go into that later. This is 1973 you're looking at. These mills were manufactured by Morgan Construction Company, and they may have even manufactured the older mills, the original mills that were in there. I don't know. I tried to research those mills and see who actually manufactured them, and I could not find an answer. So if anybody's got any information on that, go ahead and comment, because I do not know if Morgan made those original mills. Morgan construction company had been around since 1915, so it is entirely possible that they made those mills. Here's the brand new finishing mill on the back of the truck. This would have been stands 3 through 12. It looks to me like it's upside down right now on the back of this truck. The lid is sitting on top. It is not attached yet to the main body here. It would have been cool to see how they uprighted it. Yeah, I believe it's upside down because this would have been the base. That would have been what would have been on the foundation. This next one is from 1973. This is the SCR casting machine being lifted into the south door. This is the south door that they opened up on the south end of the mill. You can see the 2 idler wheels on the bottom. So there's a lot of literature online about how these casting machines work. Basically, there's a band that gets webbed through here, and a giant casting wheel gets mounted on this hub here, and the band presses onto the casting wheel, and there's copper poured into the groove in the wheel, and it's solidified. Here's the manifolds for the water sprays that would spray on the wheel to solidify the copper. So you can see 2 idler wheels. This looks like your tensioner wheel. If I remember right, this is the tensioner wheel. When you get your band on, this raises up and puts tension on it. This is the presser wheel. This is the wheel that actually presses down against the band and presses the band against the wheel. So you got your molten copper that flows into the groove in the wheel, sprays, cool the copper to solidify, and then it comes up out of the other end as a solid bar. There's another large wheel that goes onto this shaft, and then there's another unit that goes on top of this. Yeah, there's another unit that goes on top, and that has the pinch wheels for the actual bar. This is the casting machine coming into the south door, coming in on these steel rollers. This may be the hydraulics for the band tensioner wheel. The shaft furnace will be right here, so this is probably the first piece of equipment to come into the mill was the SCR casting machine. You see the guy on the bulldozer here pulling it in. This is the shell for the holding furnace, taken in 1973. So this holding furnace kind of would have been installed here. This is kind of looking in the same direction there. So the holding furnace is eventually going to get lifted up and put down into this pit here. There's no refractory brick in it right now. This is just the shell. This is the door right here, and looks like the 2 openings for the burner boxes here. This looks like it might be the foundation for the hydraulic screw jack. And then you'll notice the 2 rails here that are on the end of the furnace, and I'll explain what the reason for that is later. But this is the holding furnace. This actually holds the copper that the main melting furnace melts. So here is everything installed. This is the roughing mill that was on the back of the truck. The shaft furnace would be back here. The casting machine here, casting pit. So this picture was taken before the mill even started up. This looks like they're still getting everything ready. You can see this piece of wood still in. This is what's called a bar lifter. So whenever you cut out, this lifter lifts up the round bar that exits the roughing mill. It lifts it up. This is what's called the number 2 shear. What happens is if we're melting copper and we're casting bar, but we're not quite ready to go into the roughing mill yet, this shear will be cutting the bar into small pieces, and it'll fall into this chute. So when we're ready to have the bar go into the finishing mill, we will stop the shear. The bar will go straight into the mill, which will already be running, and we'll start going through the finishing stands. And it looks like there's a shear here. If there's ever a problem and we have a cobble, we're gonna need to cut that stuff out of there right away before it solidifies. And if you do cobble, time is important. You don't want You don't want to scorch your rolls, and you don't want to wait till that stuff gets cold, because it's going to be a real bitch to cut out of there when it cools off. Here's the finishing mill. Here's another clue that this picture was taken before its first startup, because it's being held up by chains, the lid here being held up by chains, so obviously the hydraulics aren't hooked up yet. Going back to this picture, let's see, I know I missed something here. So when you want to close this lid here, it all runs on hydraulics. So when you want to close this lid, you lift up this piece, and it goes on like a ratchet type of thing. It's held up on a latch. So you lift that up and lower down your lid, and there you go. Same thing right here. When everything's hooked up and you want to lower this lid down, you lift that up, hit your button to lower the lid, and there you go. So these are your stands here. 3 stand, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So it goes vertical, horizontal, and it just keeps going back and forth to your 5/16 inch and on your way out of the finishing mill. When I was there, I don't see it here, but when I was there was a huge lube oil tank back here. There was a giant lube oil system back there. And we actually had an engineer from Morgan come and inspect our mill, and he was one of the original installers that installed this mill. And he said that because of that lube oil system, our gearing back there looked the same way it did when he first installed it back in 1973. Just a quick story of when I was a rookie learning how to be a mill operator. So when you're running, this lid is actually going to be in the down position, and you can see the manifolds for the soluble oil sprays. When this thing is down and you're running, there's soluble oil flying all over the place. So if anything ever happens, my job as the mill operator, start up the shears, shut the oil off, and raise up the lid so we can cut everything out of there. So one day we cobbled, I go into panic mode, turn on the shears, lift the lid up, and my supervisor is standing right next to the mill the entire time. I lift up the lid so we can start getting ready to cut things out of there, and lo and behold, I forget to turn off the pumps for the soluble oil. So I sprayed half of my supervisor down with soluble oil, and yeah, he didn't let me forget it. Okay, so this is startup day, very first startup day. And I'll tell you why I think that, because look how clean the end of this holding furnace is. Perfectly clean. I guarantee you there was only one day that this furnace ever looked like that, and this was very first startup day. So startup day was February 13th, 1973. Now you can see the end of this furnace, and it'll make it easier for me to explain how this thing works. So this whole thing, this entire furnace rotates on these rails. It rolls on these rails. So it's kind of like a beer can with the opening on one end offset. So if you were to take a beer can and it was half full of beer, and you had your opening up here, and you were to rotate your beer can, the beer would eventually start spilling out of that hole. The holding furnace job is to average the flow of the main shaft furnace, because the shaft furnace doesn't always melt copper at a constant rate. There's different thicknesses of cathode. It cools, it heats. So as a furnace operator, you have to kind of maintain your holder level. And you also have different O2 contents of the different cathodes from different manufacturers. You kind of mix all that cathode together, and it kind of averages out in this furnace. Ideally, you want to keep a steady copper level in your furnace, about maybe 50-60%. What happens if you start going too low is all that refractory brick that's not covered by copper will start superheating. So your exposed refractory brick will superheat, and then when you finally kick up your firing rates in the main shaft furnace to try to make up for not paying attention, your copper will hit that superheated refractory brick, and your copper coming out of here will be too hot. So yeah, you want to keep a steady level here. The furnace had its own blower here, so I can't remember if the holding furnace had its own blower when I worked there or not. I don't remember a blower being on it, but here it definitely has its own blower with its 2 burners, and then you can see the the pneumatic piston for the door. And that's how you check your holder level, and that's how you temp it. There's a thermocouple that you got to dip in there before you start casting, because you don't want it to be too hot. Because if your copper's too hot when you start casting, your bar is going to come up liquid, and you're going to be in trouble. Looks like they rolled the holder from over here on this side back in the day. When I worked there, I had to do it from over here. It's the furnace operator's job to roll the holder. Basically, roll this holder and start copper flowing out of it. When the cast wheel is ready to start casting, I'll be standing over here. They'll give me the sign, and I will roll the holder. The reason I do it as a furnace operator is because I have a better view of the back of the pour pot, and I know how far to fill it. And so once I roll the holder, copper starts spilling out of the spout here, fill up B bowl, copper starts rolling down B launder and into the back of the pour pot. And when the pour pot gets full, they can start casting. Here's copper coming out of the holder into B bowl, then into B launder, and right out into the back of the pour pot. And you can see the back of the casting machine here. This is picture taken the same day, very first startup day. One thing I noticed is that the top of the launders are open, and they have these jets of gas going in there. We didn't have that when I worked there. We had covers for our launders, so everything was sealed up. We had a braided natural gas line that went into the launder lids, and it just these jets just shot right in there. It wasn't open like this, so it made for better temperature control and better for controlling your O2. Because I'd imagine having everything open like this, you'd get a lot of O2 in your copper. We had a pretty strict requirements of O2 content in the final rod, and I won't tell you what that is, because even though I don't work there anymore, I would kind of want to maybe have a job there again. So I'm not disclosing anything that can't be already found online, but that's a specific number that I'm not going to disclose. But it was in the parts per million. This is the cathode elevator. This is our cathode. This is how we got the cathode in its raw form. This is the cathode elevator. It looks like they probably weighed it over here. Gets put on the elevator and lifted up to the top of the shaft, where it's pushed off the car into the top of the shaft furnace. One of my videos that I have, and you'll see there is an actual conveyor here that the copper rolls along, and that was already ripped out when I worked there. In my video, you can see the remnants of that old system in the floor where they cut it out. This old elevator was not there when I worked there. We actually had a skip car, which is pretty much an elevator, but we loaded it directly onto the skip car, and it kind of went up at an angle. But it still had that same hydraulic ram up at the top that pushed the cathode into the top of the furnace. All of these cathode bundles came with the steel bands around them, and it was very important not to forget any steel bands, because while we weren't melting steel would absolutely melt in the shaft furnace here. You do not want any steel in your copper. Copper being heavier than steel, the steel would actually float on top of the copper. So I can actually see if there was some black stuff floating on top of the copper when it came out of the tap hole on the shaft furnace. I can tell that the forklift driver probably left one of the bands on and it got melted. This is the casting pit, February 13th, 1973, first startup day. This picture was taken from floor level, so this is actually down in a pit. You got B bowl, B launder, and the pour pot right in there. This is the shroud over the casting wheel. You can't really see the casting wheel from here because this is over it. You got your bar conveyor. So basically how this works is the copper comes down, the launder dumps into the pour pot. There's a spout right here. Copper comes out of the spout right here into the wheel. Wheel comes around, it is cooled off by the sprays. It solidifies and comes up as a bar. So this right here is the actuator for the metering pin, which is basically a long tungsten carbide pin that goes into the spout of the pour pot. So when they get ready to start casting, this actuator will back that tungsten carbide pin out of the spout, and copper will flow through there. And the tungsten carbide metering pin could be screwed down or out to meter the flow of the copper, because you don't want it filling up the wheel and spilling over. You'll get wings on the bar. I'll show you some wings in a minute. But wings on the bar is basically when you have you put too much copper in the wheel and it squishes out, and some of the copper gets pinched between the band and the wheel, and you get extraneous copper coming out. You can kind of see some of it. No, this bar looks good. There's no wings on it. That's shear number 1, which is operating at the moment. These pinch rollers. These pinch wheels only pinch the bar when the shears are going. As soon as you turn off the shear, these lift out, and they don't grip the bar anymore. So as soon as they stop the shear, these the crop bars will stop falling into the bin here, and it'll travel through the mills and begin being formed in a rod. You can kind of see the band here. So as this band comes around, it hits an acetylene sooter, and all this sooter does is, well, exactly what it says. It's a sooter. So there's an acetylene flame on the band, and it coats it with a layer of soot. So your soot is basically acting like a release agent. So when the wheel comes around and the bar solidifies, it doesn't want to stick to the wheel. It just peels right off. We used to stand right here. A couple guys would lower the band into the pit, and there'd be a couple guys in the pit, and they'd put the band and web it around the rollers. These are your electromechanical max-on shut-off valves, safety valves. Same thing, just from a different view. When I was there, this control panel was still down there. You can still control everything from this panel here, but from where this picture is taken, there was actually a casting booth, and there was another set of controls in that booth, so you didn't have to spend the entire shift down in the pit. When everything's running right, you go and sit in the air-conditioned booth, and you can control everything from there. I don't remember what this thing was. I don't know. It was some kind of wipe, some kind of band wipe. I just don't remember what it did. I don't remember that being there. It might have been. I just don't remember it. Here is your pour pot. You can kind of see it. 2 burners for the pour pot. Here's the wings I was talking about. So you really don't want wings on the bar, but in case you do get wings on the bar, there's a bar prep station, and I'll explain the principle of that in a second. But it's further down the line here. But yeah, wings on the bar. That meant you had too much copper come out of the pour pot, and it squished out, and it got caught between the band and the wheel, and you get this little squish out action here. There's a fan blowing. We wouldn't have had a fan blowing on us back in the day when I worked there, because you run a chance of raising the O2. So you got molten copper down here, and that fan blowing on that molten copper could introduce more O2 into the rod. So we wouldn't have had a fan blowing because our O2 levels were tightly controlled. Level indicators on the holding furnace here, full and empty. Here's a cross section of the casting wheel, so you can get a better idea of what that looks like. That's not exactly what ours look like, but basically your band would butt right up against here, and your pour pot spout would dump copper into this groove here, and so you have like a puddle of copper. And so as this wheel's turning around, you got a puddle of copper here pressed up against the band, which presses around the entire wheel. And as it goes around, it's cooled off by the water sprays, and it comes up the other end solid. And so that's what happened. Pretty much when you have the puddle too full, it'll squish out, and copper will squish between the edges of the wheel and the band, and create wings on the bar. And that is what this next station is for. This is called bar prep. This machine here, basically the top corner of the bars are surrounded by rotating blades, and it takes those wings off and makes real nice edges, nice clean edges on the edge of the bar. So when it starts going through the mills, it's nice and even. Because we had some pretty sensitive sensing equipment up at the top of the coiler that would sense for any abnormalities in the bar or iron inclusions. This is taken from the top of the pickling line. After your bar comes up out of the cast wheel, it goes through the bar prep area. Then it goes through the roughing mill, which is stands 1 and 2. At this point, it's something called round bar. Then it goes through finishing stands 3 through 12. It comes up through this pickling line, and there's been a number of pickling boxes here that douse it with an isopropyl alcohol and water solution. And on its way up, it gets brightened and it comes out the other end shiny. Got the shaft furnace over here. You can see the path that the molten copper takes out of the shaft furnace. Down here, down A launder into A bowl, into the holding furnace, subsequently into the casting wheel. You can see our crop bar conveyors, cropping the bar after it comes out of the roughing mill. If you're not ready to go into the finishing mill, the crop bar comes up here, falls down into the box. Then when you're ready to go into the finishing mill, you turn off the shears, and there you go, you're in. Off to the pickling box and coilers. These are pour pot preheater stations. We always kept 2 pour pots on preheat just in case we had a problem in the pit where we had to replace the pour pot. We wouldn't have to wait for one to heat up, it would be already heated. You just take it with the crane and take the old pour pot out and put the new one in. There's the ramp that goes down into the casting pit. Cathode elevators right here. This is your mill control panel. It's out in the open here. When I worked there, this had a booth around it as well. A nice air-conditioned booth. In the background, you can see the round bar entering the roughing mill. So this is round bar. This is basically just a round bar. This is what it looks like when it comes out of the roughing mill stand number 2. There's a bar lifter there. You got your soluble oil pumps right there. This is what I was supposed to shut off before I opened up the mill when I soaked my shift supervisor with soluble oil. You got your mill speed there, if I remember right. E-stop, of course. Your electric motor, amps for the rougher, amps for the finisher. This is the coiler here. This is a different coiler than when I worked there. One of the old timers said that this holding device here was called a stem pack. I don't know how true that is, but yeah, it just got put onto these weird holding devices called a stem pack. I don't know if they were meant to be shipped out like this or what the story with that is. February 13th, 1973, this could have very well have been the first coil. So basically, after the rod goes through the pickling line, it hits a turn down and it changes at 90 degrees and it comes down this way. So it's heading down towards the floor, and then it goes through something called a J-tube, and it kind of curves it off to the side, and the J-tube is spinning around very slowly, and it hits a bump plate. And the bump plate is spinning around too, and it's slightly offset, and that's how you get these coils to look so nice. This is the linkage for the fins. So there's fins in here that hold the coil up here. So while this coil is done, in order to cut it off, these fins close and it holds the coil because it's continuous cast, so it never stops. So the next coil is forming up here, but it's sitting on a set of fins. So as soon as the worker cuts that and cuts off a sample for the lab, this pallet will move on and these fins will open and the next coil will drop down. It's a never-ending process. This picture was taken later than the last series. You can see the holding furnace is all dirty now. There's shit laying everywhere. I do not know when these pictures were taken. There was no date on them at all, but it was definitely sometime later. So you can see the bottom of the shaft furnace. That's the tap hole. So this is called A launder. And everything was closed when I worked there. This had tops on it and had proper gas lines going into it, flexible gas lines. This had a lid on it, so there was no exposure to the outside atmosphere. It was O2 was very, very tightly controlled, and this was my opportunity to get slag out. So there was a big 50-gallon drum. We had a slag spoon. Just scoop the slag off the top and dump it into the bin and have it shipped off to be refined. So with the launder being covered and the bowl being covered, we didn't have to fire so high. There was no need to fire these burners so high, and It was a lot easier on the refractory that way and got more life out of it. Used less natural gas. There's the back end of the cathode elevator. These are ceramic fiber boards. And believe me, it's really hot here. Even with these ceramic fire boards here, this guy's he's got a face full of heat right now. Okay, let's finish this up. Picture number 40. This is going to be, again, sometime in the 1970s. You can tell they've been running for a while. They have the end of this holding furnace is quite dirty. Another thing is the guards on this control panel are no longer painted yellow. So I don't know if they must have had to replace it for some reason. The only reason I could think of they would have had to do that was because they might have had some problem with the bar and they had some wild bar come up and probably fall down on it and damage it. Because when you have problems down the line, you can't just stop the casting wheel because you can't let this bar solidify in the wheel, or you can't let it get hard in the wheel. So you got to keep casting until you run out all the copper in the pour pot. So when you do that, sometimes it comes up here and becomes a loop of spaghetti and falls back down and damages things, and that might have been what happened here. You can see this is the mezzanine up here. I think this was the engineer's office, and then my control room had the same type of windows. It was over here out of view here. So the shaft furnace would have been right here, and then the control room for the furnace would have been up here. You can see shear number 1 is running, so they're not milling it. Pinch rollers are clamped down on the bar, and you can see the tungsten carbide metering pin right here. That's a good view of it, and the actuator for it. Next picture. Strangely enough, the guard is painted again, so great. You can see the 2 burners for the pour pot kind of angled out towards the ends. They have proper braided hose. Right here you can actually, this is a good view of the band that comes around and presses up against the wheel. You can see the wear pattern where the copper comes in contact with the band, and then the wear pattern from the actual edges of the wheel. Band wipe, still don't remember what the hell that was. This band does have to be replaced often. Can't remember the intervals, but sometimes every now and then a crack will appear in the band, and it'll be just a small little crack, and you can get by with it for a while, but then you're going to start getting iron counts in your copper from the sensing equipment up by the coiler, and then it's going to cause imperfections in the bar, and it's going to show up as imperfections in the rod eventually. So you can get away with a crack, and then eventually when it gets too bad and you start getting counts, you're going to have to cut out and replace that band. This picture 72, unknown year, but it might be just prior to them retooling the mill, because it looks like they might have stocked up on rod. You can see all the stem packs here with plenty of coil on it. There was no way we would ever stored rod outside. We would have never let it oxidize like that. Whoops. You can see the big gantry cranes over here that move the reels of cable around. See the power plant, which was still standing. Looks like a movable boxcar ramp. You used to take the forklift, they pull the boxcars up here and take the forklift and put the ramp in the boxcar so you can get the cathode out, or maybe the rod in, depending on what they were doing back then. This building back here was still there when I worked there, and it was torn down when I worked there. And the only thing I know is this was called Building 90. I have no idea what was in it. We used to use it for storage. I just remember going in there and seeing a couple turntables in the floor, and don't really know what they were for. Building 90, that's all I know. Let's see, this picture is, I think this was taken sometime in the 1980s, the mid-1980s. You can see the shiny coils, so they definitely have already gone through the retooling process. This is the stack for the shaft furnace. This might be an oxygen tank, or this might be the oxygen tank. I don't know. This is an acetylene truck. They had acetylene tanks on here for the acetylene sooters. There's Building 90 again. You can see that they've taken down most of the gantry crane and its supporting infrastructure. The foundry, which was over here somewhere, is gone. The power plant is gone, but this is what was called the merchandise building for Western Electric. The famous water tower is back here. Okay, so during one of our down days, I decided to do some exploring and climbed up to the top of the shaft furnace, and then went to the old cathode elevator machine room, which was higher than the skip car we used when I was there. And this thing was up there. It is a 710 connector, cutter, presser, modular splicing toolkit. No idea what that is. This definitely looks like something that would have been custom made at the Hawthorne Works by one of their specialized departments. It's all aluminum construction. Handle just kind of spout welded in there. The handle itself is steel. This is, let's see. I had a Crown Victoria, and this thing fit perfectly in between the wheel wells in the trunk, so I had this in my trunk for years. Hilarious. It didn't really work, and it was quite dangerous. You can Google that and see what that was. Have a box within a box. A couple compartments here. Now this is a diagram of what was supposed to go in this box. When I found it, none of this stuff was in there. It was just full of coils and stuff. And alright everyone, well, I appreciate you hanging out with me and listening to me drone on about the rod mill. You know, given the state of the world now, I don't know if I'm going to be here in 4 months or anybody else is going to be here in 4 months, but so clearly my skills are not in speaking or presenting, but I just feel that I should pass on everything I know about Western Electric and the rod mill, because I don't think there's a lot of people left around that have actually worked at this facility. So everything I know, I told you. Let's just take a minute to look at this Western Electric logo, because you will not see anything like this ever again. A naked man with wings holding thunderbolts in his hands with a jumper cable. If this man flies down to jumpstart your car, I would, yeah, it's over. Over. Many of the pictures here were taken 10 years before I was born, so to me it's history. So I hope you guys enjoyed it, and just like that, the video ends.